Hello and welcome to yet another recurrence relation video of Cornerstones of Math. Today we are going to solve this recurrence relation where the first term a1 is equal to 3 and an plus 1 to the power of n is equal to 3 times an to the power of n plus 1. First, let us observe the given recurrence relation to find the most efficient approach to solve this. We have some terms in the exponents, and we usually don't like that. So what is one way to remove such exponent terms? Logarithms, right? So let us take logarithms on both sides. More specifically, let us take log base 3, since that will give us the simplest result. Then we have n log base 3 of an plus 1 on the left-hand side, and this is equal to 1 from this 3, then plus n plus 1 times log base 3 of an. And let's observe again. We have n's on both left-hand side and right-hand side, and also n plus 1 on both left-hand side and right-hand side. But we want those n's and n plus 1s to be gathered in one place because that's easier to deal with. We can achieve that by dividing both sides by n times n plus 1. It will give the left-hand side log base 3 of an plus 1 divided by n plus 1. And on the right-hand side, let's deal with this term first. It will give log base 3 of an divided by n. And the remaining 1 becomes 1 divided by n plus 1. This is the form where we can apply substitution for simpler expression. Letting log base 3 of an over n as bn, we can write the recurrence relation as bn plus 1 on the left-hand side, and this is equal to bn plus 1 over n plus 1. And the first term of sequence bn is log base 3 of a1 divided by 1, so just log base 3 of 3, hence 1. This is one of the most famous types of recurrence relations, where the difference sequence bn plus 1 minus bn is given. Here we can obtain general term bn by b1 plus, then we add up the difference sequence bk plus 1 minus bk, where k changes from 1 to n minus 1. So we have b1, which is 1, plus sigma 1 over k plus 1. K is from 1 to n minus 1. Some of you might have noticed that this is the summation that can be carried out by partial fraction method. That is, this is equal to 1 plus sigma, and we can write the fraction as 1 over k minus 1 over k plus 1. So we have this expression where terms get cancelled out. So we obtain 2 minus 1 over n. Here, notice that the calculation we carried out makes sense only when n is greater than or equal to 2. However, if we compare the result with the value of b1, you can notice that this general expression also works for n equals 1. So we can say that this works for n greater than or equal to 1. Therefore, from log base 3 of an over n is equal to bn, we can obtain an, which is 3 to the power of n times bn, which gives 3 to the power of 2n minus 1 for all natural numbers n. And that's all for today's video. Thank you for watching. Please don't forget to hit that like button if you enjoyed this video, and I will see you in another video.